Good evening, my dear students. So today we are going to start CET questions in continuity chapter. So the problem is, so here mainly continuous definitions. We have very less definitions are there. So continuous, how do you say that f is continuous? Limit of f of x as x approaches to 0, as x approaches to a, is equal to f of a, then f is said to be continuous. Whenever there is breaking conditions, so this meaning also I have to have, right? Limit of f of x as x approaches to a minus is equal to limit of f of x as x approaches to a plus is equal to f of a. So this is the meaning of continuous. If left hand limit is equal to right hand limit is equal to f of a, then f is continuous and x is equal to a. Then we have to say that discontinuous. How do you say that discontinuous function? The first, there are so many conditions are there. The condition number 1, left hand limit and right hand limit exist and are not equal, then f is discontinuous. Second point, left hand limit and right hand limit exist and are equal but not equal to f of a, then f is said to be discontinuous and x is equal to a. In the same manner, if f of a is not defined, then it is discontinuous and x is equal to a. If left hand limit both at least one of them not exist, at least one of them means here left hand limit, right hand limit, any one of them not exist, then also it is called discontinuous. So here we have to learn some more properties also. So what are the properties in theory classes I have given? Those are every polynomial function is continuous. This is the shortcut things, remember all of you. Every polynomial function is a continuous for every way. Every constant function is continuous everywhere. For all real numbers, everywhere means for all real numbers. Next one is every identity function. Identity function is always continuous. Identity function is always continuous. These properties always you have to know down. The next one, trigonometric functions, sin x, cos x, are continuous at their domain. So what is the domain of cos x and sin x? Is real number. So these are continuous for everywhere. It is continuous. Continuous meaning what? Draw a graph without lifting pen. Okay, continuity means it means without break. Without break is called a continuous. Next, mod x problem. Mod x function is continuous at their domain. What is the mod x domain? At all real numbers, minus infinity to plus infinity. Log x, logarithmic function is continuous at their domain. So what is the log x domain? Positive real numbers. So 0 to infinity. And exponential function, it is continuous 0 to infinity at their domain. Tan x is continuous at their domain only. So it is not defined, tan x graph is not defined at x is equal to 2n plus 1 of pi by 2. So it is a discontinuous at all these numbers. So where it is continuous? So it is tan x is continuous except all multiples of pi by 2. Similarly, cot x is continuous except multiples of pi. Except multiples of pi. The same manner, sec x and cosec x. Cosec x is continuous at multiple of pi by, that means everywhere except this value, sec x also same multiples of pi. So remember these functions also. Next, algebraic functions. What are the algebraic continuity functions? I consider two functions f and g. F is a continuous, g is a continuous. Then addition is also continuous for every. Subtraction is also continuous for every. Okay, addition, subtraction, as well as multiplication is continuous everywhere. And division f by z is continuous provided g of x not equal to 0. So these are the algebraic continuous functions. Sin x, cos x both are continuous. Sin x plus cos x also continuous. According to some properties, we can easily say that the function is continuous or not. Okay, you remember all these properties in theory also given properties, everything. Okay, now we have to start the questions. So the question number 1 here, they are asking like this. If f of x is equal to 1 upon 1 plus e raised to 1 of 1 by x, if x is not equal to 0, 0 if x is equal to 0, then f of x is. So how to check whether the function is continuous or discontinuous? We have to follow a method. Methodically, mathematically we do that. Never get a mistake. We never made a mistake here. So what is the methodical? The first thing, f of x value find out. At where we have to discuss this one, we have to check at x is equal to 0. So f of x is already given. At x is equal to 0, f of 0 is 0. Okay, this is the f of 0. And also we have to find left hand limit, right hand limit. So left hand limit meaning if x not equal to 0 meaning there are two inequality conditions are there. Either x is less than 0 or x is greater than 0. Okay, smaller than 0, more than 0, the function will be same. So you can do it directly also in this question, or else you can do like this. So if you want left hand limit concept method, I will explain to you. Limit of f of x as x approaches to 0 minus. Methodically I am doing here. And one more thing you remember, every differentiable function is continuous. But the converse may not be true. Every continuous function may not be differentiable. Clear that is? To keep in our mind this point. So this is equal to limit of, I would have changed x approaches to 0 minus. How do I change this is in other form? Limit of f of 0 minus h as h approaches to 0. So this is the meaning of left hand limit, that is smaller than 0. If you subtract some h, some number that is very small number, h is the small quantity. This is always lies between 0 and 1. It always lies between 0 and 1, remember. So between 0 and 1, you take any number, a small number, negligible quantity, limit value that is. If you subtract from 0, it should be always smaller than 0. Correct? For example, 0.1. Subtract from 0 minus 0.1, it will be smaller than 0 always. It is clear cut. Now this I can write. This is equal to limit of, this is h tends to 0, f of x is, this is a function, when smaller than 0 same number is there. I have to write 1 upon 1 plus e raised to 1 divided by, so x replacing, so fill x is equal to minus h. X is equal to minus h this is. Then you apply the limit. So you apply the limit. This is equal to 1 upon 1 plus e raised to minus 1 divided by 0. Okay, 1 upon 0 is equal to, we know that is 1 upon 1 plus e raised to minus infinity. You know very well e raised to minus infinity value. So e raised to minus infinity nothing but 1 upon e raised to infinity. This is equal to 1 upon infinity. 1 upon infinity is 0. So you clear cut this is e raised to minus infinity is 0. So 1 upon 1 plus 0 is equal to 1 divided by 1, that is 1 only. Okay, 1 divided by 1 plus 0, that is equal to 1. We got left hand limit is equal to, left hand side value, left hand limit is equal to 1. You can approach same method in right hand limit also. So right hand limit, just I will show. That is, how do I represent? Limit of f of x as x approaches to 0 plus. 0 plus that is more than 0. If it is more than 0 means that is right hand value. So right side from right side. So as x approaches to 0 positive from the right hand side. This is also I could convert. I could have right. So more than 0 means something will be added, no? Something is added for 0. That is limit of f of 0 plus h as h approaches to 0. Okay. Now we should substitute that this is equal to limit of 1 upon, that is, so replacing x by 0 plus h, that is h. 1 plus e raised to 1 divided by h as h tends to 0. Now we have to fill, we have to apply limit, simplify. This is equal to 1 upon 1 plus e raised to 1 divided by 0. Okay, that is equal to 1 upon 1 plus e raised to infinity. E raised to infinity we know that. That is what? E raised to infinity is infinity only. So this is equal to 1 over 1 divided by 1 plus infinity also infinity. 1 by infinity is equal to 0. Okay. I got left hand limit is equal to 1. Right hand limit is equal to 0. F of 0 is equal to 0. As according to our theoretical part, so here left hand limit exists, right hand limit exists, but are not equal. These are not equal means what do you say that this is not a continuous at x is equal to 0. So that is not a continuous meaning discontinuous at x is equal to 0. So like we should explain all things in the continuity mode. So continuity chapter very important, compulsory. There is one problem in JEE main, in CET also. Okay, very simple models are there, very easy to find out continuity things. Mainly we should remember left hand limit, right hand limit when there is breaking conditions. However, there is a breaking conditions, we follow left limit, right hand limit values. Okay, this is the model to find the continuity. Sometimes using properties we can say also directly. So today we have first class, so we should learn very slowly also. Shall I go next question? Okay, problem number 2. What is the second question of the limit? So I have removed this one. So after this is common means I will remove this problem. So you remember e raised to minus infinity value, that is 0 always. See the problem number 2. If f of x is equal to e raised to 1 divided by x minus 1 upon e raised to 1 divided by x plus 1 when x is not equal to 0. 0 when x is equal to 0. When x is equal to 0, f of x is, so this is x is smaller than 0, this is x is more than 0. Okay, so we have to check out this one, whether is it a continuous or not a continuous. So continuous and related with the differentiable given, don't worry, that is very easy to find. Okay, we have to discuss here only continuity means. Firstly, when x is equal to 0, f of 0 is 0, it is clear, that is written already. Now left hand limit, that is smaller than 0, function is the same, I should write like this. Now I have to substitute here directly, that is e raised to 1 divided by minus h minus 1 upon e raised to 1 divided by minus h plus 1. This is the f of 0 minus h value. Now apply the limit. This becomes e raised to minus 1 divided by 0 minus 1 upon e raised to minus 1 divided by 0 plus 1. So e raised to 1 by 0 we know all of it, that is infinity. So this is e raised to minus infinity minus 1 by e raised to minus infinity plus 1. As we know, e raised to minus infinity will be 0 always. So 0 minus 1 divided by 0 plus 1, this is equal to minus 1. So we have left hand limit is equal to minus 1. So no need to find right hand limit also. Left hand limit exists. f of 0, observe that these two. Is it a continuous? No, here not satisfied. It is not a continuous. Okay, if it is not a continuous means maybe it is not a differential. So here limit, right hand limit also we can check up like this. Limit of f of x as x tends to 0 plus. Okay, but every differentiable function is a continuous, but every continuous function may not be differentiable. So it is not a continuous, we can say that it is not a differentiable also. Answer will be more, that is might be fourth option. Okay, this is the answer of this one. Check once again if you want right hand limit, don't clear out. Right hand limit exists or not, check up. 0 plus f of x, f of 0 plus h, limit h tends to 0. Substitute here e raised to 1 divided by h minus 1 divided by e raised to 1 divided by h plus 1. Whenever you apply the limit, it becomes what? Infinity by infinity form. So indeterminate form. So whenever there is indeterminate form, we need to convert as determinate form. How do I bring in the determinate form? Simply, I would have write this value limit as h approaches to 0, I would have take e raised to 1 by h common in both numerator and denominator. If I take e raised to 1 by h common in both numerator and denominator, this becomes 1 minus 1 upon e raised to 1 by h divided by e raised to 1 by h into 1 plus e raised 1 upon e raised to 1 by h. So like we are getting also. Then it is converted in the determinant form. Actually, if you apply limit, it is indeterminate form, infinity by infinity, indeterminate form. So we have to bring in the determinate form. Here e raised to 1 by h get cancelled. Now apply the limit. We get 1 minus 1 by, this is 1, e raised to minus infinity. That is 1 minus 0 by 1 plus 0, this is equal to 1. Okay, so now what happened? Left hand limit, right hand limit exists but is not equal. Hence it is not a continuous at x is equal to 0. It is not a continuous at x is equal to 0 means it is not a differentiable also. So let us see the differentiable functions means a limit of f of x plus h minus f of x by h mod. Let me check the differentiability. Here it is not a continuous. Okay, it is not a continuous means anyone is satisfied here. Differentiable is there. Continuous means only none of these options will be there. Clear? So like we have to solve the questions. Continuity model, next of this is only process. And also along with this one we have to learn, remember, that is L'Hospital rule. L'Hospital rule meaning what? Differentiate numerator and denominator separately. In first PUC, I explained those L'Hospital rule in the limits. So with the help of limits problems, we can easily solve continuity problems. Mainly limits is important here. We will see more things in limit chapter also. So see the continuity problems like this we have to discuss. Next question. Third question. See the problem number 3. What is the third question? F of x is equal to x when x is rational. 1 minus x when x is irrational. Then 4 options are given. F of x is continuous for all real x, discontinuous for all real x, continuous only at x equal to 1 by 2, discontinuous at x is equal to 1 by 2. Okay. I would have checked at one rational number. Already there is a rational number 1 by 2. Let us see rational number here. Limit x tends to 1 by 2. F of x. If x is equal to here 1 by 2, this is what you call rational number. As x approaches to 1 by 2, what is the f of x value? X tends to 1 by 2. If x is rational number, what is the f of x value? That is x. This is equal to, apply the limit 1 by 2. If you add something for rational number, is it become a rational number? 1 by 2 plus something 0. So that should be what? Rational number. For example, I would have either subtract or adding 1 by 2 plus 1 by 2 plus. This is also we can write limit of as h approaches to 0 f of 1 by 2 plus h. 1 by 2 plus h. Okay. Is it a rational number? No, it is always an irrational number. becomes an irrational number. Something number added here, root 3. 0 point something added, so it becomes irrational number. If it is an irrational number, what is the function? 1 minus x. So this is equal to limit of 1 minus of 1 by 2 plus h as h tends to 0. Apply the limit. This is equal to 1 minus 1 by 2 plus 0. This is equal to 1 divided by 2. Now what is the f of 1 by 2? So f of 1 by 2 also is equal to 1 by 2, rational number. If it is a rational number also we are getting 1 by 2. So here left hand limit, right hand limit both exist here. So left hand limit, that is either left or right, same number, and f of x also, that is 1 by 2. Limit exists. Limit exists here. Limit exists and that is equal to f of a. What do you call this one? It is a continuous and x is equal to 1 by 2. Okay, it is a continuous or x equal to 1 by 2. If you want shortcut time saving model, whenever there is given two functions with the rational number and irrational number, solving these two we get the where it is a continuous function. Solving, if I solve these two, that is x is equal to 1 minus ax, this is the second method. So 2x is equal to what? 1. X is equal to 1 by 2. Okay? So by solving these two terms, we get x value, x equal to 1 by 2. This limit. And x equal to 1 by 2, it is a continuous. At x is equal to 1 by 2, it is a continuous function. Whenever there is given two functions with the rational and irrational, follow this time saving method. It is one type of shortcut. Okay, or else we can do like this. This is a methodically traditional method. This is you can easily solve continuous or discontinuous. It is a continuous and x equal to 1 by 2. I hope that you may understand this is. So rational number, I would have taken rational number. So I checked it here, f of x value and limit of a function. Both are continuous. Both are equal. If I add something also rational number, that should be also getting limit same 1 by 2. Okay, hence it is a continuous and x equal to 1 by 2. Are you okay? Very important model, rational models in the CET point of view. Then fourth question. What is the fourth question? See the problem. F of x is equal to x cube plus x square minus 16x plus 20 divided by x minus 2, where x does not equal to 2. The value which should be assigned to f of x at x equal to 2, so that f of x is continuous at x is equal to 2. So what do you understand according to this problem? At x is equal to 2, function is f of x is what? F of x is what here? At x is equal to 2. Should be assigned function f of x is at x is equal to 2. That is at x not equal to 2 given. At x not equal to 2, f of 2 is, f of x is x cube plus x square minus 16x plus 20 divided by x minus 2. Okay, I have to find limit of a function. So limit of f of x as x approaches to 2. This is equal to limit x raised to 3 plus x square minus 16x plus 20 divided by x minus 2 as x approaches to 2. Apply the limit. If you apply the limit, what is the getting value? 2 cube 8 plus 4 minus 32 plus 20 divided by 2 minus 2. We get 0 by 0 form. This is called indeterminate form. If it is an indeterminate form, so what to do? This is what you call algebraic functions. Expressions, quadratic expressions or polynomial expressions. So whenever there is a polynomial expressions, what to do here? Factorization. Or one more method, using L'Hospital rule. Using L'Hospital rule. So what is the L'Hospital rule? Differentiating numerator and denominator separately. So this is equal, I differentiate this, shortcut this is, as x tends to 2, apply the L'Hospital rule, x cube differentiation, 3x square plus 2x minus 16 divided by 1. Okay, this is equal to, apply the limit now, 3 into 2 square plus 2 into 2 minus 16. Simplify. 4 3 is 12 plus 4 minus 16 is equal to 0. We got f of x value, limit of f of x as x approaches to 2 equal to 0. Okay, but actually at x is equal to 2, what is the f of x? This is also becomes what? This is 0. At x is equal to 2 should be assigned to be f of 0 actually, that is f of x, that is. And where function is what? It is a continuous one. It is a continuous. So f of x is continuous means what? Limit of f of x at x is equal to 2 is equal to 0. Since f is continuous at x is equal to 2, that means limit of f of x as x approaches to 2 is equal to f of 0, f of 2. So that is how much we got? This is equal to 0. So f of 2 is equal to what? F of 2 is 0. Okay, since it is a continuous means limit exists. Limit of f of x as x approaches to a is equal to f of a. So this is the value. When there is whenever there is a algebraic functions are given, so generally we are applying factorization method. But instead of that, if there is a shortcut there, the shortcut 0 by 0 form, infinity by infinity form is given. So using L'Hospital rule, we have to calculate this. L'Hospital rule meaning differentiate numerator and denominator separately until the getting finite value. Okay? So we have to convert this, see a finite number. So there is no 0 by 0 form now. The first phase only 0 by 0. The second phase no 0 by 0 form. If you are getting here also 0 by 0 or infinity by infinity, again applying L'Hospital rule second time. Until the getting finite number, we should apply this process. Here second way no need. Only first time use the second time directly apply getting finite number. Since f is a continuous at x equal to 2, it means limit of f of x as x approaches to equal to f of a. This is we got answer, f of a is 0. Fifth question. So what is our fifth question of the work? For what value value the function f of x is equal to 3x plus 4 tan x divided by x at x equal to 0 is continuous. So when it is continuous only, so we have to find limit of a function only. I take the directly limit at x equal to 0. Limit of f of x as x approaches to 0. This equals limit of, what is the f of x? 3x plus 4 tan x divided by x as x approaches to 0. I have to write this one using property. I have to write limit of 3x by x 3 as x approaches to 0 plus limit of 4 tan x divided by x as x approaches to 0. So this is the property. Limit of f plus g is equal to limit of f plus limit of g of x. Limit of f plus limit of g of x. So limit of a constant is equal to, what is that value? 3. Limit of a constant is a constant plus, it is a constant outside, 4 into, do you know this value? In limits, limit of tan x by x as x approaches to 0 is equal to 1. Limit of sin x by x as x approaches to 0 also 1. So 4 into 1, this is equal to 3 plus 4, 7. This is nothing but f of 0. Why? Because it is a continuous. So when it is continuous, if limit of f of x as x approaches to a equal to f of b. So asking what is the f of 0 value? So f of 0 is 7. Are you okay this one? Next question. See the next problem. 6th question. Let f of x is equal to tan of pi by 4 minus x divided by cot of 2x, where x does not equal to pi by 4. The value which be assigned to f at x equal to pi by 4, so that it is continuous everywhere. So since f is a continuous mean, since f is continuous at x is equal to pi by 4. What is the meaning of this? Limit of f of x as x tends to pi by 4. What is the f of x value? Tan of pi by 4 minus x divided by cot of 2x, okay, is equal to f of pi by 4. This is the meaning. Limit of f of x equal to f of a. Now what I do here, how do I simplify this one? Actually, if you apply the limit in this case, we are getting 0 by 0 form, indeterminate form. Indeterminate form means we should convert into determinate form. How do I bring in the determinate form? One of the method is that we know all of you. That is what? L'Hospital rule. If it is 0 by 0. We can use determinant, that is L'Hospital rule, very easy. So what is the derivative of tan x? Derivative of tan x is secant square x. Derivative of cosecant square x is, derivative of cot x is minus cosecant square x. We can apply, no problem. Okay, using L'Hospital rule. So this is the shortcut thing. Otherwise you can do traditionally. So limit x approaches to pi by 4 here. So you apply the differentiation separating both numerator and denominator. Differentiation of 10x, we know that secant square of pi by 4 minus x into function of a function. Derivative of pi by 4 minus x is minus 1 upon differentiation of cot x, that is minus cosecant square x, cosecant square of 2x into function of a function 2x derivative is 2 in the right side same number. We should find this value f of pi by 4. Now apply that. Minus this minus cancelled, okay. If I apply the limit x is equal to pi by 4, secant square of pi by 4 minus pi by 4, that is 0. Secant square 0. Sec 0 is what? 1. 1 square is also 1 divided by cosecant square of 2 into pi by 4. Here only substitute 2 pi by 4 is pi by 2. Cosec pi by 2, cosec 90 is equal to 1. So 1 square also this is 1 into 2 is equal to f of pi by 4. So what is the f of pi by 4 right now? So f of pi by 4 is equal to 1 divided by 2. Okay. So with the help of L'Hospital rule, we can easily find out limit questions within shortly. You remember everyone, if there is a 0 by 0 or infinity by infinity, okay, we should bring into determinant form with the help of L'Hospital rule only. With the help of L'Hospital rule, we can easily solve. Why? Because here we don't want any traditional method. Here we need only answer of the question. So we should use L'Hospital rule. What is the L'Hospital rule? Differentiating numerator and denominator separately. Okay, this is the L'Hospital rule concept. Next question. See the problem number 7. What is the seventh question? If f of x is equal to x into sine of 1 divided by x, where x is not equal to 0, then the value of the function at x equal to 0, so that the function is continuous at x equal to 0. So here also function is continuous. Since f of x is continuous at x is equal to 0, this means limit of f of x as x approaches to 0 is equal to f of 0. This is the meaning that has given already, it is continuous. Now we have to find f of 0 value. Substitute here limit of x into sine of 1 divided by x as x approaches to 0 is equal to f of 0. If you apply the limit, what happens? This is equal to 0 into sine of 1 divided by 0. Do you have this value? Sine of 1 by 0? We can't say. But sine is always what? It always, what is the range of sine is? -1 and +1. It doesn't exceed -1 to +1. So it is a finite quantity. So sine of 1 by x is a finite number. A finite number is equal to f of 0. This is equal to 0 is equal to f of 0. So what is the f of 0 value is 0. So you keep in your mind, all of you, sine function always a finite quantity, less than or equal to 1. It is not an infinity number. It should be a finite number. So 0 into finite number always 0. So answer will be 1. That is 0. Okay. Some of them they changed here sin of 1 by x divided by 1 by x, but here 1 by x value becomes infinity. Okay, it is wrong. So clearly that is 0 into finite number only, that is 0. Next question. What is the next problem? Consider f of x is equal to x square divided by mod of x. F of x is equal to x square divided by mod of x. F of 0 is equal to 0, then we have to check all values. Firstly, I define the function. This is x square by mod of x, where x not equal to 0, and 0 when x is equal to 0. However, whenever there is a mod function, we have to break into cases by using mod x function definition. This is also equal to x square divided by minus x if x is smaller than 0, x square by x if x is more than 0, 0 when x is 0. Okay, this is nothing but minus x when x is smaller than 0 plus x when x is more than 0, 0 when x is equal to 0. So the simplified function this is only. Now we have to check whether it is a continuous or not at x equal to 0. At x equal to 0 already has given f of 0 is 0. Left hand limit to find out LHL. That is the limit of f of x as x tends to 0 minus. This is I convert limit of f of 0 minus h as h tends to 0. This equals limit of observe 0 minus h meaning what? Smaller than 0. If x is smaller than 0, when x is smaller than 0, what is the f of x value? Minus x. So minus of x is what you write? 0 minus h. So apply the limit. This becomes also 0. Similarly, in the same manner we have to calculate right hand limit. Limit of f of x as x approaches to 0 plus more than 0, right hand limit. I have to write limit of f of 0 plus h as h tends to 0. This is equal to limit. What is the, if x is more than 0, what is the f of x value? X. Substitute here 0 plus h as h tends to 0, applying limit also 0. So what I have done here, at x is equal to 0, left hand limit exists, right hand limit exists, and also f of 0 is 0. Hence it is a continuous only at x equal to 0. F of x is continuous only at x equal to 0. Okay, at x equal to 0 it is a continuous function. This is also. Next problem, 9th one. The value of f of 2 so that f of x is equal to 2 raised to x plus 2 minus 16 divided by 4 raised to x minus 16 is continuous at x is equal Continuous, already it is a continuous. What is the value of f of 2? Since f is continuous, that x is equal to 2. What is the meaning of this? That is, limit of f of x as x approaches to 2 is equal to f of 2. We have to find limit only. Apply the function here. Limit of, what is the function? 2 raised to x plus 2 minus 16 divided by 4 raised to x minus 16 as x approaches to is equal to f of 2. I have to find f of 2 value. If I apply the limit, what happens after that? 2 raised to 2 plus 2, that is 2 raised to 4. 2 raised to 4 is 16. 16 minus 16, 0. Here 4 raised to 2, 4 square. 16 minus 16, 0. So what do you call this one? This is 0 by 0 form. If there is 0 by 0 form, what do you call this one? Indeterminate form. If it is in indeterminate form, how to bring in the determinate form? One of the method is L'Hospital rule. Can we apply L'Hospital rule? Very easy. So using L'Hospital rule, differentiating numerator and denominator separately only. Actually, this is 2 raised to x form. I can write this is also 2 square value 4 into 2 raised to x minus 16. Okay, same value. Apply the limit here. What is the differentiation of a raised to x? A raised to x derivative is a raised to x into log e. So 4 into 2 raised to x into log 2 minus derivative is 0 divided by 4 raised to x derivative 4 raised to x into log 4 minus 0 is equal to f of 2. Now you apply that. X tends to 2. So 4 into 2 square, that is 4. 4 into 4 log 2 divided by 4 square log 4 is equal to f of 2. 4 square value 16. 16 cancel. What is the f of 2 value? Log 2 divided by log 4. A raised to x into log e. Okay, na? A raised to x into log e. So log 2 divided by log 4. So options are not given. This model. Log 2 divided by. So this becomes f of 2 is equal to log 2 divided by log 4. Also I can write log 2 base 4. Also this is x tends to 0, x tends to 2, and x equal to 2 only, correct? Okay, it is a raised to x derivative a raised to x into log e. 4 into 2 raised to x into log 2 divided by 4 raised to x into log 4. So log 2 base 4 also correct. This is also I can write log 2 base 2 square. This is 1 by 2 log 2 base 2. Okay? According to logarithmic property, this is equal to 1 by 2 into 1 is equal to 1 divided by 2. Check up the answer is option number 2. Okay? Logarithmic property. So logarithmic property is very important. Log A divided by log B is equal to log A to the base B. Next, remember log A B raised to m is equal to 1 divided by m log A to the base B. If there is a base and logarithm same, answer will be 1. Log a to the base a equal to 1. So like we have to answer the questions one by one. We have to see the next video remaining problems. Okay?